Hi, and welcome back to Dirt Killer Pressure Washers. I'm the original Josh, and today we're going to take a look at the Radial Axial pump design and compare it to crankshaft style designs. So here we have a cutout assembly of a pump and motor by Krensley that has a radial axial pump on an electric motor so that we can see how it functions and how it actually works when we're using it. And then here we have two examples of crankshaft style pumps. One shows you a single cylinder of the pump and how that one cylinder works. And then this cutout shows you the system with 3 plungers so you can see how they all work together. First, let's talk about the similarities between the two styles of pumps. Pressure washer pumps create flow. They're not producing any pressure themselves. We don't get pressure until we take a constant amount of water flow and force it through a constant amount of restriction of a certain size. So both of these style pumps are doing the same thing. They're just pushing water forward and making sure it can't go the other direction. So in order to accomplish that, in both systems, they both use a plunger, as we see right here, a plunger to pull water in and push water back out. And we can see here on the crankshaft pump, when we rotate the crankshaft, we get in and out movement of the plungers on the pump. Similarly, on the radial axial pump, as the motor shaft comes around, the wobble plate presses the plungers in and springs pull them back out. So in both cases, got the same system of moving water, which is a plunger. And in order for the water to stay within the housing, both have water seals, or what we call packings. We have them here in this valve housing, and they're also visible here in the Krensley pump. Both pumps also use check valves to force the flow of water to maintain one direction. So if our plunger is acting like a syringe and pulling water in and pushing water back out, it's not necessarily going to keep maintaining the same direction of flow. So in order to accomplish this, the forcing the flow into one constant direction, on all pressure washer pumps, the plunger is pulling water into the cylinder past a lower check valve, which is often referred to as the intake or low pressure check valve. And then when it comes back forward, it's pushing the water back out of the cylinder up through a second check valve, which is referred to as our discharge or high pressure check valve. So we see where that's present in this pump, and then we can also see it right here in the front of the valve housing on the Krensley pump. Both also have oil housings. You know, this is the oil housing of the crankshaft pump, as is this. This is the oil housing of the radial axial pump. So both of them require lubrication. They're both going to have an oil housing, and consequently, to keep the oil in there, both have oil seals and different O-rings to keep your oil in your oil bath. Same is true for this crankshaft pump. And then we can also see it here within the valve housing of the radial axial pump. So essentially, both style systems are doing the exact same thing. They're converting rotation of a motor shaft. So in this case, we've got your motor shaft spinning right here. On this pump, we can look through the window here. We got a crankshaft rotating and pushing our plungers in and out. So both of them are taking rotational energy from our motor or engine and then converting it into flow inside the valve housing. So now we'll take a look at the differences between the two styles of pumps. As we can see, both systems have 3 sets of plungers, which is why we have 3 valve caps across the front and top of the valve housing for this crankshaft pump. And then the same is true here for our radial axial. We have 3 plungers inside, so we have 3 sets of check valves for that as well. That makes both of these pumps triplex pumps. Basically just means each one is 3 systems of plungers and check valves working together to force flow. Now where they differ is that the crankshaft style pump, much like the crankshaft in an engine, has lobes on it. There are connecting rods holding on to those lobes, and then as the motor or as the motor rotates the shaft of the pump, we'll see the connecting rods pulling that plunger out and pushing it back in. Looks very similar to the drive assembly on a locomotive or an old style train. You've got that rotation around the crankshaft is causing our in and out motion of the plunger. Conversely, in our radial axial pump, we don't have connecting rods. You can see in here the mating connections between the shaft of the pump and the actual plungers is different. In here, the shaft runs this way, but the plungers run this way. So they're running perpendicular to one another. In the radial axial pump, here is our motor shaft, and our plungers are also facing straight forward. So in a radial axial pump, the plungers are parallel to the motor shaft, which for one creates less loss of efficiency when we're converting the motion from one to the other. Secondly, with our connecting rods pulling the plungers out and pushing them back in, every time the plunger switches directions, the crankshaft of the pump is doing all the work. It's got to force the plunger in and pull it back out. This is where one of the major differences in the radial axial pump. In the radial axial pump, we have what's called a swash plate or a wobble plate, and it's essentially just an angled cam. If this was a cylinder and we cut an angled plane through it, we would get somewhat of a triangular cylinder. That's what the base of the wobble plate looks like. In the front of that is a bearing set that allows for smooth conversion of motion from the rotation of that wobble plate to the back surface of the plungers. Now you'll notice as the wobble plate goes around, there's a high side and a low side. The high side of the wobble plate is pushing the plunger back in. However, when it returns to its neutral position and is pulled back out, that motion is controlled by the springs that are on the back end of the plungers. So the motor that's creating the motion inside of the pump only has to do the work of pushing the plungers in. It doesn't actually have to pull the plungers back out, so it's not using that energy for that particular purpose. As a consequence, there's less loss of efficiency with a radial axial pump versus a crankshaft style pump. You know, they're doing the same thing, but this can do less work to accomplish the same task. Now, there are some other very significant differences between our radial axial pump and our crankshaft style pump, and we're going to focus specifically on Krensley's radial axial pumps. In crankshaft style pumps, almost 95 to 99% of the time, the plungers are a mechanical, basically just a cylinder coming through that either has a threaded stem sticking off of it or can take a bolt to go into that back end of that plunger, and that holds on a ceramic sleeve. The reason we use ceramic on our plungers is that when the pump is rotating, with this pump, that plunger's making 3,600 journeys in and out of the pump every minute because our engine is spinning at roughly 3,600 RPM, as is the pump. So this is going in and out real fast. When water seats in the microscopic pores of the ceramic, it provides a hydroplaning reaction to the water seals that allows your packings, which is both a high pressure and low pressure seal, that gives it the ability to retain that fluid inside the valve housing and prevent it from leaking back out of the pump or into your oil bath. On Krensley's pump, it can be somewhat challenging to see, but here inside the valve housing we can see the tip of the plunger where it is actually a stainless steel plunger that has the ceramic laminated to the surface of the plunger. As a consequence, the way that these plungers can crack from freeze damage or from exposure to long periods of bypass where no fresh water is introduced to the pump and no heat's being carried away, if these get extraordinarily hot, we squeeze the trigger, fresh cool water is introduced into the pump. These are notorious for shattering, especially on residential applications, as well as when an untrained operator is using the machine. They don't realize that they need to make sure that the pump doesn't sit and continuously run while they're not spraying, and that's when we see the plungers crack. Because the ceramic lamination is actually on the surface of the plunger for the Krensley pump, that actually helps to transmit heat from the valve housing back to the oil bath in the transmission housing, and it also makes that ceramic much more sturdy because it's just a coating on the outside of the plunger as opposed to a sleeve of ceramic. Some other differences between our Krensley pump and these crankshaft style pumps. As I previously mentioned, this is a 3600 RPM or a direct drive pump. It will spin the same speed as the motor or gasoline engine that's driving it. Both the gas-powered Krensley pumps as well as the electric motor Krensley pumps are all run at about half that RPM, somewhere around 1700 to 1800 RPM, and as a consequence, there is less friction inside of the valve housing. We're creating less heat, less wear on water seals and other components, because every time the plunger makes a pass in and out, a check valve's got to open and close. So all these things are happening many sequences per minute, thousands of sequences a minute. Because this is spinning at half the RPM, it's only getting half as much wear, so to speak, as the crankshaft equivalent. Additional things that are common about radial axial pumps, and is true for almost all of Krensley's modern pumps, is that they have an integrated unloader valve assembly, which redirects the water flow whenever we release the trigger on the gun and shut off the outlet of the water flow. And then in this unit, we also have an integrated pressure switch assembly so that total stop can be added to this, or it can also control other features like a burner system on a hot water unit. So those features being integrated into this pump are ideal for the styles of machines that we use them for, because then all of the components are built within, and they also, all the parts are Krensley, whereas with your crankshaft style pumps, if it has an external unloader valve, the unloader valve is often never the same brand as the pressure washer pump. So you get different parts from different manufacturers. Then if we need service parts, we're ordering from different places. So this is a takeaway for using one system that's all together made by the same manufacturer. So there you have it. We have taken a look at the Krensley radial axial pump versus its crankshaft style counterparts in the industry. If you have more questions, feel free to reach out to us at dirtkiller.com. Don't forget to like, comment, and subscribe. This is the original Josh with Dirt Killer Pressure Washers. Let's kill some dirt.